In this video, we are going to talk about script and functions. A script is a sequence of statements stored in a file. It's a simple form of a program in MATLAB, and as some of you already did, this is used to create as a .m file, which is a file you use to submit to Canvas as your homework. You can actually run the script by just type the file name at the command window, but you also want to make sure that it's your current folder. So for example, we have a script named recursion in our current folder. If we just in the command window type the name recursion, then we'll be able to run this script. And now we get the value in the workspace. Note that we don't have to have this script show up in our editor. As long as in our current folder, we are able to call this. Now I would like you to go to your folder where you have your homework. Run the script by typing the file name in the command window. Try to see if you can run your script, the script you submit as your homework. For your future, when you submit your homework, I want you to make sure your file name is readable in MATLAB and can be directly executed by typing the name in the command window. From now on, your file name will count towards your homework grade. There are several things to keep in mind while you want to write a script. First, we want to make sure you understand the problem. What are our input? What's the output? What's the given value? What are the unknowns? What's the problem you're trying to solve? Next, we want to make a plan. You want to specify how each step is going to be complete. You can do it by a flow diagram or pseudocode, which we discussed very early in this course. Then, we'll execute the plan. You should first translate from a flowchart or pseudocode. Make sure you think before you code. After that, you want to evaluate your solution. Make sure the value returned to you makes sense and it is clear and correct. There is no bugs or warning. Let's take this activity in your worksheet as an example. So we want to write a program to sing happy birthday. That this program output lyrics to happy birthday song, happy birthday to you. All know this song. So what we want to do is we want to make it very general so it can sing happy birthday to anyone. If we take a look at what we want to solve, in this case, our input is going to be the name and the output is going to be the lyric containing the name. Because we want it to be generic, be able to use for everyone, so we'll first ask for a name as an input. Next step is to display the happy birthday to you. We display again in another line, now with a name, and repeat in another line. When we execute the plan, what kind of functions can we use in MATLAB in order to ask for the input and out? We have the function input to input, and we have display and fprintf in order to output. We'll talk about each function later. We'll evaluate the solution. We'll also test it and see what happens if we forget to give input. What happens instead of giving a name, we give a number. What happens if we have wrong input? Let's first take a look at the function input. It takes a form of x, which is your variable, and given your input, in the parentheses, you will have a prompt. Let's use your ice cream homework as an example. In that case, your input is going to be the length of the ice cream. We set a variable L. We assign the input, giving a prompt length of the ice cream, and then we close the parentheses and click enter. It asks us the length of the ice cream, which remember is 4. Let's just type 4. Now the 4 is assigned to the variable L. Looks like we want a space between the prompt and the number. We also want to be more specific, asking the length in terms of inches. We re-edit this. We can try the input again. Now what if we type something not in a number, but rather in 4 as of FOUR? What's gonna happen? Let's try. Oh, we got an error. Look like this input only takes numerical value. For our happy birthday, we want to input name and that's supposed to be a string. What should we do? Don't worry, we have another format of input. If we want to input string, instead of just giving the prompt, we are adding a comma. We specify single quote s as we are going to input string. Let's try on our ice cream problem again. After this, we are adding this single quote s. It's asked for input, and we input 4 as FOUR. In our command window, we see this variable becomes 4 as a character. Even if we tap the number 4, it's also stored there, but instead of using it as number, now this is a character. After talking about input, let's take a look at output. Here we have two basic output functions. First is display. The displays function output unformatted variables to the command window, and the second one is fprintf, which you can actually format your output from a program. But how do we format it? If you take a look at this table below here, On your left-hand side, this indicating where you want to refer it. The percentage tells us we are going to point it to something. C is a character, S is a string, and F is a fixed point. Right-hand side, you see how we want it to be printed. For example, the first one, /n, that is telling us to print in a new line. For the ice cream problem, we want to display the mass of the ice cream. We assign this 124 to the mass. Then if we do display mass, then it is going to show us 124 here. However, we want it to be a complete sentence saying mass of the ice cream is something. We can set this the mass of the ice cream as a string and displays this string. But now we still need this number 124 somewhere in this sentence. Okay, the mass of the ice cream can be one element, 124 can be another element. Can I just put those together? Alright, MATLAB doesn't like it. Display can only do unformatted strings, which means whatever you give to the display, it displays that. You cannot add on other parts. So what can we do? You can actually assign these into a variable, let's say x. Put the mass of ice cream as our first element and mass as our second element. Remember, mass here is a number, so you want to convert this number to a string. Now, if we do display x, it is able to show us the whole sentence, the mass of ice cream. We said fprintf can output formatted string. So let's try with fprintf. We type fprintf, then the file ID, the mass of ice cream is. Now we want to refer this value to this mass. We want to set up a pointer, which let's use a percentage mark. This is a number, it is integer, so let's use d. This unit is gram. We finish this sentence, we use a comma, then refer to mass. Now it shows us the mass of ice cream is 124 grams. However, this has been printed in the same line. We want to print in a new line, so we want to add it on a /n. Now this has been printed on a new line. Besides using input and output such as display fprintf, we can actually write a function that calls for input and output. Function is actually a special type of script that is a list of statements a programmer creates that give a specific name with a predefined input, process, and output. And we can input by calling the function's name with a parenthesis and output to a variable. If you click the triangle under the new and you will find a function. If you click on that, that will create a function in your editor, and you see the function start with the name function. You output in the bracket untitled2. Here is a name, we haven't defined it yet. Then your input in the parentheses. Then you have several lines to process, and by the end you write end to end this function. But remember, your function name must be a valid identifier. So you cannot start with a number, or you cannot use plus or minus sign or some other signs which are not being accepted. Also, MATLAB would use the same name as the function name as a file name. Here, let's take a look at this function called foo. Here, x is our input and y is our output. If we type in the command window, assign foo5 to y, then we'll have y output as 7. Now if we do a y plus 1, that will give us 8. However, if we do x plus 1, that shows us x is not defined. Yeah, this is weird because we actually defined the x in our function, but why we cannot use this x? This is because functions perform all calculations using a temporary function workspace. All the input-output variables used within the function will be just storage in the function temporarily, not be able to use it outside of the function. If we do a breakpoint, we'll be able to see the difference. We set the breakpoint at line 3, so it will execute the line 2. Call this function again. We assign foo5 to this y. Now it's at line 3. Yeah, we have x is 6. If we continue, now we'll see, oh, actually x is gone. Now we only have y. That means all the variables will be only storage in the function.